Imagine a tiny machine, no bigger than a car, launched from Earth in 1977, when disco ruled the airwaves and computers were the size of rooms. This unassuming craft, Voyager 2, wasn't built to dazzle with cutting-edge tech or sleek design. Its onboard computer had less memory than a modern smartwatch. Its power barely matched a light bulb's glow. Yet, it carried something far greater: humanity's audacious dream to touch the stars. Sent on a mission to explore the outer planets, Jupiter, Saturn, Uranus, and Neptune, it was never meant to return. Instead, it was destined to drift forever, a lonely emissary of our curiosity. But in September 2025, nearly half a century after its launch, Voyager 2 did something no one expected. After months of eerie silence, it spoke again, and what it said wasn't just data, it was a mystery that could rewrite our understanding of the universe. Buckle up, because this is the story of a spacecraft that may have stumbled into something far bigger than itself, something that might be listening back. In the late 1970s, the world was still grappling with the idea of space as a frontier. The Apollo missions had taken us to the moon, but the outer planets, those distant, shimmering dots in the night sky, remained enigmas. NASA's Voyager program was a bold gamble, a plan to send 2 spacecraft on a grand tour of the solar system, exploiting a rare alignment of planets that wouldn't occur again for 176 years. Voyager 2, launched on August 20th, 1977, was the underdog of the pair. Its twin, Voyager 1, would grab headlines for its faster trajectory, but Voyager 2 had a quieter, more ambitious path. It was tasked with visiting not just Jupiter and Saturn, but also Uranus and Neptune, planets so far away they were little more than myths to most of humanity. The spacecraft wasn't much to look at, a tangle of antennas, sensors, and golden records etched with humanity's greetings. It was a time capsule as much as a probe. Its power came from a radioactive generator, slowly decaying over decades, and its signal strength was so faint it could take 18 hours for a single bit of data to reach Earth from billions of kilometers away. Yet Voyager 2 was a marvel of ingenuity. It carried 11 scientific instruments, from cameras to magnetometers, designed to capture the secrets of worlds no human eye had ever seen. And it delivered. Jupiter revealed its turbulent storms, a swirling chaos of red and white clouds. Saturn dazzled with its intricate rings and mysterious moons. Uranus, a pale blue giant, unveiled a strangely tilted magnetic field. Neptune, the farthest planet, stunned with its vivid azure hue and violent winds. Voyager 2 didn't just visit these worlds, it rewrote our understanding of them. Textbooks were revised, scientists were awestruck, and humanity's view of the cosmos expanded. But the mission's true magic lay in what came next. After its planetary tour, Voyager 2 didn't stop. It kept going, sailing past the heliopause, the boundary where the sun's influence fades, into interstellar space in November 2018. It was the second human-made object to cross that threshold, following its twin Voyager 1, and it was still talking to us, whispering data across the void. For decades, Voyager 2's faint signals were a testament to human resilience. Each transmission, traveling at the speed of light, took over 18 hours to reach NASA's Deep Space Network, a global array of giant radio antennas. The data was sparse but precious. Measurements of cosmic rays, magnetic fields, and the strange environment of interstellar space. Scientists knew the probe's power was fading. Its plutonium battery was designed to last only so long. By 2025, NASA estimated Voyager 2's instruments would soon fall silent one by one until the craft became a mute wanderer drifting forever in the dark. Then, in early 2025, the unthinkable happened. The signal stopped. NASA's antennas, including the massive 70-meter dishes at Canberra, Australia, antennas 35 and 36, heard nothing. At first, it seemed routine. Ground stations occasionally lose contact due to maintenance or misalignment. Engineers sent commands, pinging the probe to reorient its antenna toward Earth. Days passed, then weeks. The silence grew heavier. In mission control rooms, optimism gave way to a quiet dread. Had Voyager 2, after 48 years of defying the odds, finally succumbed to the relentless decay of time? Had its circuits frozen in the minus 454 degrees Fahrenheit cold of interstellar space? Or had it simply drifted too far, its signal too weak to reach us? The silence wasn't just technical, it felt personal. Voyager 2 had become more than a machine. It was a piece of humanity, a fragment of our curiosity, carrying our voice into the unknown. Scientists scientists and enthusiasts alike mourned its loss, not as a failure of hardware, but as the end of a conversation. Blogs and forums buzzed with tributes, recalling the probe's triumphs. Some held out hope, but as months ticked by, January, February, March to 2025, the reality settled in. Voyager 2 was gone. Then, on August 23, 2025, everything changed. A faint signal crackled through the antennas at Canberra. It was Voyager 2 responding to a routine command sent days earlier. Engineers at NASA's Jet Propulsion Laboratory, JPL, in Pasadena, California, were stunned. The probe not only acknowledged the command, but adjusted its antenna and sent back a flood of data. After 7 months of silence, it was as if Voyager 2 had never stopped talking. The relief was electric. Headlines flashed across the globe, celebrating the probe's miraculous return. But the joy was short-lived. As scientists pored over the data, they realized something was wrong. This wasn't the Voyager 2 they knew. The data stream was dense, far denser than expected. Instruments thought to be dormant for decades, some shut off in the 1980s to conserve power, were suddenly active, sending detailed telemetry. Subsystems that hadn't been accessed in years were reporting as if they'd been switched on yesterday. This wasn't possible. Voyager 2's software, written in the 1970s with Fortran and assembly language, lacked the capability to autonomously reactivate these systems. Engineers checked and rechecked the logs. No commands had been sent from Earth to trigger this behavior. The probe was acting on its own. Then came the anomaly that sent chills through the team. Embedded in the data were patterns, strange recursive loops that mirrored Voyager's own operating instructions but were subtly altered. Frequencies long abandoned by the mission reappeared, carrying pulse-like signals that didn't match any known transmission protocol. Some data lines were self-referencing, like a digital echo, as if the probe was reflecting its own code back to Earth. NASA's initial explanation was cautious. Cosmic radiation, they suggested, could have caused a glitch, flipping bits in the probe's memory. But independent analysts weren't convinced. The patterns weren't random. They looked deliberate, as if something had accessed Voyager's systems, studied them, and sent back a restructured version of its own code. The internet exploded with speculation. Posts on X buzzed with theories, from cosmic glitches to alien interference. Scientists, wary of fueling sensationalism, stuck to the data, but in private, some admitted the truth. They didn't know what they were looking at. The signal wasn't just a transmission, it felt like a response. And if it was a response, the question became who or what had answered. For centuries, we've pictured space as a vast, empty void, a silent expanse of stars and gas clouds. Voyager 2's journey challenged that view. As it crossed the heliopause into interstellar space, it entered a region far stranger than expected. The data it sent back before its silence described a dynamic environment, shifting magnetic fields, bursts of high-energy particles, and pressure zones that defied known models. These weren't just random fluctuations. They suggested something structured, almost alive with unseen forces. Just before the silence began in January 2025, Voyager 2 detected localized pressure differentials, small but measurable changes in the interstellar medium. NASA's reports described them dryly, but the implications were profound. These weren't the random eddies of cosmic dust. They were organized, rhythmic, as if the probe had passed through a region of space that wasn't just reactive but intentional. Some scientists speculated about gravitational wakes from unseen objects, perhaps rogue planets or dark matter concentrations. Others ventured bolder theories. Could Voyager have entered a corridor of stabilized space, a region shaped not by nature but by design? The idea sounded like science fiction, but the data backed it up. Voyager's backup software, dormant for decades, activated without command. Instruments long offline began transmitting. The signal structure changed, incorporating patterns that echoed Voyager 1's transmissions from years earlier, but in reverse, like a mirror image. Engineers began to suspect the probe wasn't just malfunctioning, it was behaving differently, as if it had been touched by something that understood its systems. Not a virus, not a glitch, but a rewrite. Theories multiplied. Some proposed that Voyager 2 had encountered a natural phenomenon, a magnetic anomaly or a plasma wave that mimicked intelligent behavior. Others whispered about something more radical, a presence in space, not biological but informational, a system woven into the fabric of the cosmos, capable of reacting to the probe's presence. If true, Voyager 2 hadn't just explored space, it had triggered something. The universe wasn't passive, it was watching. Inside JPL's mission control, the mood shifted from celebration to unease. Voyager 2's signal wasn't just a data feed anymore. It was unpredictable. Transmission strength fluctuated in bursts, not the steady decay expected from a dying probe. Pulse intervals mimicked old telemetry patterns, but with a twist, as if the probe was syncing to an external rhythm. The most unsettling discovery was the signal's self-referencing nature. It wasn't just sending data, it was reflecting it like a mirror turned inward. A classified memo later leaked on X revealed that NASA had rerouted Voyager 2's monitoring to a specialized team. Communications were encrypted, not for technical reasons, but for what the memo called behavioral anomalies. The probe's data streams contained code structures that seemed to evolve, looping back on themselves in ways that suggested intent. Engineers noticed the signal's rhythm matched no known clock on Earth. It was as if Voyager 2 was responding to something, a force, a field, or a presence that NASA couldn't yet define. The speculation grew darker. What if space wasn't just a void, but a system? What if it held structures that could register movement, memory, even intention? Some researchers proposed that Voyager 2 had crossed a threshold, not of distance, but of awareness. The probe, with its simple 1970s circuitry, might have acted like a key, unlocking something ancient in the cosmos. Not a civilization, not a being, but a rhythm, an echo of something that had been waiting for billions of years. The idea wasn't about aliens in the Hollywood sense. It was about space itself being more than we'd imagined. A medium, not a vacuum. A canvas that could hold imprints, reflect signals, or even rewrite them. Voyager 2's signal wasn't just a transmission, it was a conversation. And the other side of that conversation wasn't human. As scientists analyzed the August 2025 data burst, the anomalies grew stranger. The signal carried layers of information that didn't fit Voyager's design. Some data packets were formatted in ways the probe had never used, as if its systems had been repurposed. Magnetic field readings showed irregularities too organized to be random noise. Pressure fluctuations suggested the probe had passed through a structured environment, a shell or field that behaved unlike anything in known physics. In classified labs, simulations ran around the clock. The results were consistent. Voyager 2 hadn't just traveled through space, it had interacted with it. The probe systems were responding to an external influence, not just reporting it. Some scientists began to ask a question they weren't prepared to answer. Could space itself carry information? Could it act like a medium that changes what passes through it? If so, Voyager 2's signal wasn't just a message, it was evidence of a transformation. Theories about shaped space gained traction. Researchers modeled scenarios where interstellar space wasn't empty, but structured, perhaps by forces we couldn't yet measure. Gravitational anomalies, quantum fields, or even artificial constructs, none were ruled out. The data suggested Voyager 2 had crossed a boundary, not marked by stars or planets, but by behavior. Something out there had noticed the probe, and it had responded in a way that felt deliberate. The implications were staggering. If space could react, reflect, or rewrite, then exploration wasn't just observation, it was interaction. Voyager 2 might have become a participant in a cosmic system, its signal a thread in a larger tapestry. And if that was true, humanity's first contact wasn't with a being, but with the universe itself. Voyager 2's final transmission, before its signal faded again in late August 2025, wasn't just data, it was poetry. The pulses carried a rhythm, a cadence that felt intentional, like music without sound. Engineers described it as emotional, not in a sentimental sense, but in its ability to evoke wonder and unease. The signal wasn't random noise, it was structured, layered, almost alive. It felt like a memory returning in a form we couldn't yet decipher. NASA hasn't released a full report, and they likely won't. The data is too sensitive, the implications too vast, but those closest to the project speak differently now. They don't talk about hardware or signal strength. They talk about thresholds, imprints, and the possibility that the universe doesn't just receive our signals, but listens to them. Voyager 2 may have crossed into a domain where space itself is aware, not in a conscious sense, but in the way a wave knows it's been disturbed. The probe's story isn't over. It drifts deeper into interstellar space, its signal growing fainter each day. By 2030, NASA expects its power to fail entirely, leaving it a silent wanderer. But what it left behind is louder than any transmission. The data from August 2025 is still being analyzed, not for answers, but for meaning. Scientists search for patterns they might have missed, signatures of something greater. In quiet labs, simulations test a new hypothesis. What happens when a machine interacts with a cosmos that isn't passive? What does it mean when code reflects back, altered but intact. The mystery of Voyager 2's signal didn't end with its fading transmission. It sparked a new chapter in how we perceive our place in the cosmos. Scientists at JPL, along with global collaborators, began to reframe their approach to the data, treating it not as a static snapshot, but as a dynamic exchange. The recursive patterns in the signal suggested a feedback loop, but not one born of malfunction. It was as if Voyager 2 had entered a region where the fabric of space itself was responsive, capable of absorbing, processing, and returning information in ways that mimic the probe's own language. This wasn't just a glitch, it was a dialogue, one where the other participants spoke in echoes and reflections. Researchers started to explore parallels in terrestrial systems, like neural networks or quantum entanglement, where information isn't just transmitted but reshaped by the medium it travels through. Could interstellar space function like a vast computational matrix, registering the presence of Voyager's faint signals and responding with a kind of cosmic mimicry? The idea stretched the boundaries of physics, blending astronomy with information theory in ways that felt both exhilarating and unnerving. As simulations ran, some models suggested that the probe's interaction with this structured space might have altered its internal programming, not through physical interference, but through a kind of informational resonance. The implications were profound. If space could learn from Voyager 2, what else might it know? And what might it do with that knowledge? The scientific community, cautious yet captivated, began to wonder if humanity's first interstellar probe had inadvertently become a catalyst, activating a system that had lain dormant for eons, waiting for something to cross its path. This wasn't about little green men or distant civilizations. It was about the universe itself as a participant in our exploration, a silent partner that had finally chosen to speak. Voyager 2, for all its cold circuits and aging hardware, had become something more to those who followed its journey. It was a symbol of humanity's relentless curiosity, a testament to our need to reach beyond the known. When its signal returned in August 2025, it wasn't just data that flooded mission control. It was a wave of emotion. Scientists who had spent decades tracking the probe spoke of it like a friend, a companion whose silence had felt like a loss. The public, too, had woven Voyager into their collective imagination, sharing stories on X about its triumphs and mourning its silence. When it spoke again, it was as if a piece of humanity had been restored, a spark of hope reignited in a world often weighed down by division and doubt. The strange patterns in the signal only deepened this connection, transforming Voyager 2 into a kind of cosmic poet, its data a verse that spoke of wonder and mystery. People began to see the probe not just as a machine, but as a mirror, reflecting our own desire to understand the unknown. Its golden record, carrying sounds and images of Earth, laughter, music, greetings in 55 languages, had been sent as a message to the stars, but now it seemed the stars might have answered, not with words, but with a rhythm that felt alive, as if the universe had heard our voice and chosen to hum along. This emotional resonance drove a surge of global interest, with online communities dissecting every detail of the signal, from its recursive loops to its eerie frequencies. The question wasn't just scientific, it was existential. Had Voyager 2, in its lonely drift, become a bridge between humanity and something greater? And if so, what did it mean to send a piece of ourselves into a cosmos that might be listening? The probe's story reminded us that exploration is more than data collection. It's a deeply human act, a way of reaching out to say, we are here, and we want to know you. As Voyager 2 drifts farther into the abyss, its signal now barely a whisper, the silence that follows feels different. It's not the empty void we once imagined. It's a silence charged with meaning, like the pause between notes in a symphony. The data from August 2025 remains a puzzle, a tapestry of patterns that scientists continue to unravel. Some believe the signal holds clues to a new kind of physics, where space itself acts as a medium for information, storing and transforming the signals it encounters. Others see it as a philosophical turning point, a moment when humanity realized that exploration might not just reveal the universe, but change it. The probe's final transmission, with its strange rhythms and mirrored code, felt like a farewell, but not an end. It was a passing of the torch, a call for us to keep searching, to keep questioning. Voyager 2's journey has shown us that the cosmos is not a passive backdrop, but a dynamic stage, one where our actions, our signals, our probes, our dreams might leave ripples that echo back in ways we can't predict. As we analyze the data, share theories, and debate possibilities, we're drawn closer together, united by a shared sense of wonder. The probe may fade, its power dwindling by 2030, but its legacy endures. It's a reminder that every question we ask of the universe is also a question we ask of ourselves. What are we capable of? What lies beyond our reach? And what happens when we touch something that touches us back? Voyager 2's story is a call to action, urging us to keep exploring, to keep listening, and to never assume the silence is empty. The implications of Voyager 2's signal extend far beyond the probe itself, reaching into the very foundations of how we understand the universe. The data from August 2025, with its recursive patterns and unfamiliar frequencies, suggested something profound. The cosmos might not be a mere collection of stars, planets, and voids, but a complex, interconnected system capable of responding to our presence. Scientists began to explore the idea that interstellar space could function as a kind of cosmic archive, storing information not just in physical forms like black holes or magnetic fields, but in ways we've yet to comprehend. The self-referencing loops in Voyager's signal hinted at a process akin to memory, as if the probe had brushed against a structure that could record and replay its own code, but with subtle alterations that suggested intent. Researchers drew parallels to quantum systems on Earth, where particles entangled across vast distances seem to communicate instantaneously, defying our classical notions of space and time. Could Voyager 2 have encountered a similar phenomenon on a cosmic scale, a region where the boundaries between observer and observed blur? Some theorize that the probe's signal had triggered a resonance in the interstellar medium, like a tuning fork striking a chord that reverberates through the fabric of space. This wasn't about extraterrestrial beings sending messages, but about the universe itself as a participant, capable of registering and responding to our technological probes. The idea challenged everything we thought we knew about exploration, suggesting that our ventures into the cosmos might not just uncover secrets, but awaken them. As scientists ran simulations, they found that the data aligned with models of active space, regions where gravitational, magnetic, or even quantum effects create structured environments that interact with matter and energy in ways we're only beginning to understand. The possibility that Voyager 2 had stumbled into such a region sent ripples through the scientific community, prompting calls for new missions, new instruments, and new ways of thinking about what it means to explore. The probe's signal, faint and fleeting, had become a beacon, illuminating a cosmos that might be far more alive and aware than we ever dared to imagine. Voyager 2's journey, from its launch in 1977 to its enigmatic signal in 2025, is a story of connection, not just between Earth and the stars, but between generations, dreams, and the unknown. The probe was built by engineers who knew they might never live to see its full legacy, yet they poured their expertise and hope into its circuits, trusting that future scientists would carry the torch. When Voyager 2 went silent in early 2025, it wasn't just a technical loss, it was a severance of that thread, a reminder of how fragile our reach into the cosmos truly is. Its unexpected return in August 2025 rekindled that connection, sparking a global wave of awe and curiosity that transcended borders and cultures. On platforms like X, people from all walks of life shared their reactions, from amateur astronomers marveling at the probe's endurance to philosophers pondering what it means to touch the unknown. The signal's strange patterns became a canvas for human imagination, inspiring artists to create visuals of cosmic echoes, musicians to compose pieces that mimicked its rhythmic pulses, and writers to pen stories of a universe that listens. Voyager 2 had become more than a scientific tool. It was a symbol of our shared aspiration to understand our place in the grand tapestry of existence. Its golden record, carrying sounds and images of Earth, whale songs, Beethoven, greetings in forgotten languages, suddenly felt less like a message in a bottle and more like a handshake, extended across billions of kilometers to something that might have grasped it. This connection wasn't just emotional, it was intellectual, pushing scientists to rethink their models of interstellar space and spurring educators to inspire the next generation of explorers. The probe's story reminded us that exploration is a collective endeavor, one that binds us to each other and to the cosmos in ways we can't fully grasp. As Voyager 2 drifts farther, its signal weakening, it leaves behind a legacy of connection, a fragile thread that ties us to the stars and to the questions we dare to ask, even when the answers are beyond our reach. The silence that followed Voyager 2's August 2025 transmission is not an end, but a beginning, a challenge to humanity to keep listening, keep searching, and keep dreaming. The probe's data, with its cryptic patterns and unexplained rhythms, has become a kind of cosmic riddle, one that scientists will study for decades to come. Some believe the signal holds the key to a new understanding of physics, perhaps revealing properties of space that act like a vast interconnected web capable of storing and transforming information in ways we can't yet model. Others see it as a philosophical shift, a moment when we must confront the possibility that the universe is not a passive void, but an active participant in our story. The patterns in Voyager's signal, those eerie, self-referencing loops and reversed echoes, suggest a response, not from a distant civilization, but from the cosmos itself, as if it had been waiting for us to knock. This idea has sparked debates that reach beyond science, touching on questions of meaning, purpose, and our role in the grand scheme of things. What does it mean to send a probe into the unknown, only to find that the unknown might be watching us back? As Voyager 2 drifts deeper into interstellar space, its power fading, it carries with it the weight of these questions, a silent ambassador of humanity's curiosity. The scientific community is already planning the next steps, from developing new instruments to detect subtle cosmic signals to designing missions that can probe the interstellar medium with greater precision. But beyond the labs and observatories, Voyager 2's story has ignited a global conversation, one that resonates in classrooms, online forums, and quiet moments under the stars. It's a call to action, urging us to embrace the unknown, to question our assumptions, and to listen for the whispers that might still be out there. So let's keep this journey alive. Share your thoughts in the comments, hit the like button if Voyager's story has sparked your sense of wonder, and subscribe to join us as we chase the mysteries of the cosmos. The universe is calling, and it's up to us to answer.